Here is question number 11, everyone. A spherical object of mass m and radius r is released from the top of smooth inclined plane of height small h and angle of inclination 37 degree. The radius of gyration of object is capital K. The speed of object at the bottom of inclined plane will be what? Now, suppose this is the inclined plane and particle has been released from the top of incline and there is no friction. Finally, it reaches at the bottom. We have to calculate the speed right here. It has started from here, that's why velocity will be 0 here. Height is given h. It is clearly mentioned that the surface is smooth, so that's why there will be no friction, means there will be no agent which will provide the rolling. This is not the case of rolling, object will only slide. So we can write, since inclined surface is smooth, therefore there will be no rolling. Now the particle is coming from top of incline to the bottom without rolling. It's just sliding, so we can apply the conservation of mechanical energy. The total mechanical energy at the top will be mgh only, equals the total mechanical energy at the bottom, that is half mv square, where v is the speed at the bottom. Cancel out and we can write speed at the bottom equals under root 2gh. So after looking at the options, we can say that option number 1 is absolutely correct and we will go with option number 1. Now let us proceed to the next question, that is question number 12. So here we are having question number 12. A person at equator of earth feels that his weight is reduced by a factor of 2 of present weight at equator of earth. Then duration of day will be what? The question belongs to the topic variation in the value of g with rotation of the earth, which is given as g dash equals g minus r omega square cos square lambda, where lambda is the angle of latitude of the point where we are calculating the g dash, effective value of gravity. In question it is clearly mentioned that weight is reduced by a factor of 2, means g dash is g by 2. For equator, lambda will be 0. Equation can be written further, g by 2 equals g minus r omega square cos square 0, which is obviously 1. So from here, after solving, we get the value of omega as g divided by 2r under root. Now the time period t we know very well, that is 2 pi by omega. Therefore t will be 2 pi under root of 2r by g. Now this can be written further, under root 2 times 2 pi under root r by g. This value is clearly understood by us, known by us, that is 84.6 minute. So therefore we can write the time period t will be what? Under root 2 times 84.6 minutes, which is about 1.98 hours, and can be written further 2 hours. And after looking at the options, we can say that we have to go with option number 2, which is absolutely correct. Now let us proceed to the next question, that is question number 13. Here is question number 13, students. An object is projected in upward direction with a speed of under root gr by 6 from a height h equals 2r above the surface of earth. The speed with which object will collide the earth's surface. We have to neglect air drag. R is the radius of earth and m is the mass of earth that is given in the question. Now the situation says, suppose this is the earth, center at O, particle is released from point A, suppose, which is at a height to r from the surface. Now the motion of particle will be something like this. It will reach at the surface, suppose with some velocity v. This is point A and suppose this is point B. Gravitational force is acting on the object, which is a conservative force, so we can apply the law of conservation of mechanical energy. Mechanical energy here will be conserved. Means the total mechanical energy at A must be equal to the total mechanical energy at B. Mechanical energy at A will be what? Potential energy at A plus kinetic energy at A, which is equal to mechanical energy at B, potential energy at B plus kinetic energy at B. Potential energy at A. Two mass system, potential energy can be written as G, mass of Earth, mass of particle divided by distance of particle from the center of Earth, that will be 3r, plus kinetic energy at A, half m v square, that is given gr by 6 under root. So if you do the square, under root will be removed, equals potential energy at B. The particle reached at the surface, so it will be gmm divided by r plus of half mv square, where v is the speed of the particle while hitting the ground. Small m, small m, small m, small m will be cancelled out. Now what we are going to get now? Minus of gm upon 3r plus gr. We know very well that gm equals gr square. So simply gr can be written as gm by r. So using this concept, we can write gr as capital G, capital M upon capital R, where 12 is already there, so 12r. Bring this to the left hand side, we get plus of gm by r equals v square whole divided by 2. Now taking the LCM, what we are going to get? 3r, 12r, r. 12r will be the LCM, minus 4gm plus gm plus 12gm equals v square divided by 2. 2 6 ja 12. After solving this, we will get minus 4 plus 13, that is 9gm divided by 6r as v square. So after solving, we can say that speed will be under root 3 by 2 gm upon r. And after looking at the options, we can say that option number 1 is absolutely correct. So we will go with option number 1. Now let us proceed to the next question, that is question number 14. Here is question number 14. An ideal gas of adiabatic exponent gamma expands according to the law PV equals beta, where beta is a positive constant. For this process, compressibility of gas will be what? We know very well compressibility equals 1 by bulk modulus, which we denote with B. Now, according to given equation, PV equals beta. Differentiating both sides, what we will get? Here, product rule will be applied. First into differentiation of second plus second into differentiation of first. Beta is a constant, so we get 0 here. Let us divide it by delta V. Both sides, we will get P equals minus of V delta P divided by delta V. Now, if you see this particular thing, we will say that this is a bulk modulus actually. That is the expression for bulk modulus. So we got pressure directly equal as bulk modulus. Therefore, compressibility will be reciprocal of pressure 1 by P. And after looking at the options, we can say that option number 1 is absolutely correct. So we will go with option number 1. Now let us proceed to the next question, that is question number 15. So here is question number 15. If water is ejecting from a hole of radius small r at a depth h from the water surface in cylindrical vessel of diameter capital D, then the speed with which the water level in the vessel drops considering area of the hole is comparable to area of vessel. Now the question is combined application of Bernoulli's theorem as well as continuity equation. So let us consider a vessel filled with liquid up to level capital H from the bottom. Now there is a hole at a depth h from the surface of water. Suppose the speed with which the water is ejecting here is V2, area is A2, radius of the hole is R given in the question. Diameter here is D, area is suppose A2, and the speed with which the level of liquid is dropping is suppose V1. So this V1 we have to calculate. Now let us applying the Bernoulli's theorem. We will get P1 plus rho V1 square upon 2 plus rho G capital H, which will be equal to P2 plus rho V2 square upon 2 plus rho G small h minus h, as this h is always taken from bottom. Now rho GH will cancel out. P1 will be cancelled out as P1 and P2 are the atmospheric pressures. So after solving, we will get rho V1 square upon 2. Let's bring this left term, that is rho G small h, toward left hand side. We'll get rho G h, which is equal to rho V2 square divided by 2. After solving, we will get the value of V2 square as V1 square plus 2GH. Now let us apply the continuity equation. We will have A1 V1 will be equal to A2 V2. Product of area and speed will always be equal. Now the value of V2 we can write A1 upon A2 multiplied by V1. This V1 we have to calculate. Putting the value of V2 in equation number 1, we will have A1 square upon A2 square multiplied by V1 square minus of V1 square equals 2GH. Therefore, V1 square will be equal to A2 square into 2GH whole divided by A1 square minus of A2 square. Therefore, V1 will be A2 under root 2GH whole divided by under root of A1 square minus A2 square. Now putting the value of A1 and A2 in the final expression, we will get V1 as A2 is pi r square under root 2GH whole divided by A1 is pi d square upon 4. If you square, then you will get pi square d to the power 4 by 16 minus of A2 square, that is pi square r to the power 4. And after solving, we will get the value of V1 as 4r square under root 2GH whole divided by under root d to the power 4 minus of 16 times r to the power 4. So this is our final expression, and after looking at the option, we can say that option number 3 is absolutely correct. So that's why we will go with option number 3. Now let us proceed to the next question.